So what we're going to go through first is just a quick overview of what's new in GitHub Enterprise 2.10, which we released a couple of months ago. And then what I'm going to do is take you through a scenario, a simple scenario, where we're going to use GitHub Jenkins to automate a deployment of your Lambda function, obviously up into AWS Lambda. So let's get stuck into that overview first. As usual, our GitHub Enterprise versions, we tend to support them for about a year before we recommend that you move on from them, or that's the latest point we recommend you move on from them. So over time, we basically provide support, hot fixes, security patches, and so forth for the product for about, like I said, the life of about a year. So in March this year, we retired 2.5. In April, we retired 2.6. And recently in August, we retired 2.7. Now, if you're still using GitHub Enterprise 2.7, that's okay. We'll provide you technical support. You can still raise tickets and things like that. But if we identify a problem or we work with you to identify something that's actually solved in a later version of GitHub, we're going to strongly advise you to be able to update to that because we're not going to be able to hot patch the older version of GitHub for you. So enough of the sad news. Let's talk about the good news. The first thing I want to talk about is enabling developers. And what we're talking about here is the stuff that your developers or yourselves are going to see in the end user interface to make it easier and more interesting to work with GitHub on a day-to-day basis. So here I'm talking about the idea of topics. Now, this is something look, to be honest, we should have brought this in a long time ago. It allows you to actually provide keywords for all your repositories. So you can see here that I'm providing a whole bunch of keywords based on what's the source code, what file type it is, and so forth. And then by adding these topics, I can then drill down and see all the related repositories that are using the same keywords. So it's a great way to get around and actually discover other repositories that are sitting within your organization that you can then work with, discover code, steal the code, things like that. Awesome, so that's topics. The next thing I want to talk about is a little bit more about how do you look at the history of changes to a file. And so those of you who work in Git have heard the concept of Git blame, where you can look at what commit actually is responsible for what change in a particular file. And we've made some improvements to that in our UI version of Git blame. So you can see here, for example, I've now looked at a particular file, and I click on the blame button. And what we do is we break the source code down into the individual sections that have been modified by a particular commit. And if you like, I can actually drill back and look through the entire history of file just for that block of code. So that's the Git blame improvements. Next thing we've added is we've had code review now in the product for quite some time, but we've been asked to be able to do things so that people can come in and filter their pull requests based on the status of the code review that's actually happened at any particular time. So now we've added filters that allow you to do this. So here I am in a particular project, and I go to the pull request page. And you can see now I can filter based on things like code that's been approved, code that's still awaiting review. We even got some special ones there to say, okay, code that's awaiting for review by me, or code that I particularly have reviewed, which are these last ones here. This allows you to filter right down to the code review stuff that's outstanding, get it out of the way, and move on to things. And with the last shortcut, obviously, a lot of our job is to actually come in and approve these pull requests. So we've given you a shortcut that basically says everything that's been approved by me or waiting for approval by me. This is kind of good because like I said, some of our important jobs, or one of our important jobs is to come in, quickly approve something and get it out there, and then move on to the next important job, which is grabbing a second cup of coffee and talking about the Game of Thrones finale last week. Awesome. So some of the things that we've also done now is we've also enabled it so that in certain circumstances, you can actually dismiss the requirement to have a code review approve code before it gets merged. We get asked for this a lot because occasionally the fix is something like a spelling fix. You know, like you're working on a web page and you've spelt the word "the" incorrectly. To go through an entire approval process in some of those situations, people don't like it, it slows them down. So we've added the ability to be able to dismiss code review in certain circumstances. It's usually done by an administrator of the repository or an owner of the organization, but we've now actually given you the ability to delegate that down. So if my friend Michael here, for example, that I want him to be able to selectively dismiss code review requests, in other words, for a spelling mistake, he can quickly go in and do it. So what I'm doing here is protecting the branch to stop it from being deleted. I'm then making sure that we can't merge into the master branch before we've actually done a code review. I've also had it so that if somebody pushes code to the branch after we've approved it, it's got to go through the approval process again. But this last one here just allows me to delegate the ability to bypass that workflow to certain trusted individuals. Don't worry, it's all logged, it's all audited, so you can still go back and look at that if you need to lay blame on something. If we now cut across to our projects, often we've been asked to be able to provide an activity view of our projects. So in other words, as you create projects, you create columns, you create cards for issues and notes, and you move things through those columns, then people have asked us to be able to track when that happened and how. So here we are with our projects. I'm just moving a couple of items here between the columns just so that we're generating some activity here. If I go up to the Show menu and select Activity, you can see now that we've got a complete history of everything that's changed in this project over time, right back to the beginning of the creation of the project. Similarly, we also understand that GitHub, we provide lightweight versions of certain things, like projects, like issues, but there are some fantastic tools out there that we integrate in with as well. Jira is a great example. Trello is another great example of products. So if you like, you can actually disable issues, and you can now disable projects within GitHub quite simply. So here I am in my repository, and you can see we've got our projects. But if I go into the settings, and we've got this little features area that I can untick the box that says projects, and now projects, as you can see, are switched off, and they're no longer available. They're not confusing users as to whether or not they're meant to be using them, and you can still go ahead and use your integrated tools like Trello as usual. All right, so that's what we've done for the end users. Let's now talk about how to extend the GitHub platform. We have the best APIs in the business, and I know I sounded like Donald Trump just then, but we do have the best APIs in the business. And so we are constantly looking at ways to improve those APIs so that we can do the best integrations with applications such as Jira and Trello and so forth. And what I want to announce today is the fact now that we're using GraphQL as the new version of our API. Are people here familiar with GraphQL? Cool people? Yep, awesome. Used a lot by Facebook, of all places. So let's have a look at a scenario, all right? Let's say that we've got an organization called the Super Apps Organization, and we want to get the name of every repository owned by that organization. And then for each one of those repositories, we want to get the title of all the pull requests owned by that organization. So those of you who are familiar with the REST APIs that we currently have in GitHub know that that's a lot of REST calls to do. All right, now I know for this particular organization that there's only one repository. So we're going to skip the first step, but let's go and do the second step. So here I'm at the command line and issue a curl command to our repository. Hit the return key, and there's some data. And I'm going to scroll back towards all the data. That's the list of all the pull requests that are owned by that repository. I've sped that up 300%, so there's a lot of data. But I know there's only 5 pull requests, and all I'm actually interested in for each one is this title. So if you're mobile or you're running on a slow network connection, that's a lot of data that you're chewing up every time you want to do something. What would be really good is to do the equivalent of this. All right, now, at the moment, I've done the same call. It's just that I've run it through a pipe locally to pull out those lines. What if we could actually do that on the server? Now we can. So let's have a look at a query as it works with their new GraphQL API. This represents a query. So for the organization Super Apps, I just want the first 100 repositories. And the only reason I'm doing that is to show you that you can page these results as well. And in reality, there's only one repo. Then for each one of those repositories, I'm just interested in the name and the pull request, nothing else. And then for the pull requests, I'm only interested in the title and nothing else. Now, the other interesting thing you can see about this is that this query also defines the structure of the data that we get back. So let's have a look at that now. So I'll just clear my screen. I've just scrunched this up into one line. And so we can see here that we've got one endpoint. Instead of all the multiple endpoints for the APIs, there's only one endpoint, the API/GraphQL endpoint. Hit return. There's our response. I'm going to grab that, pop it back over into Atom, and we're just going to expand that so you can look at the structure a little bit better. And we're done. And you can see now that what we've got is well-formed JSON that's already ready to process. You don't have to muck around with it. It's literally all the data that you actually requested and needed in the format by which you did the query in the first place. So as you can see, if you're writing apps for mobile or you're writing applications to integrate with GitHub on what could be potentially bad network connections, not that we have any in Australia, you know that you're basically going to be able to reduce that data footprint, reduce that bandwidth, get your applications running faster with GitHub. But we haven't forgotten the version 3 of the API update, so we're still working on that because obviously we don't expect you to get all your apps over into GraphQL straight away. So what have we done there? So in terms of the API endpoints that we've got in place now, we used to have a couple that were in preview, in beta mode, that we had publicly available. So now we've taken those out of preview so that you can work with those directly in your applications and know that they're not going to change in a great way over time. So the merge methods API that allows you to determine how a merge is going to take place, whether it's a rebase or a squash, that can now be determined via an API call. You notice that we did the projects before. All of that can be driven via an API, so you can remotely create projects, you can remotely create columns, you can create cards, move cards between columns. All that can be done via an API calls. And obviously, you can then manage the users that are working within repositories via the API. They've all come out of preview and are now basically regarded as in production. What we've also now brought in that's currently in preview is that, as you noticed before, we did the protected branches when we were talking about code review. You can actually now trigger remotely a flag that also enforces admins to follow the same workflow as the general users do of your repository. This could be very important in areas around regulatory control or compliance to make sure that everybody is following the same workflows. Now, in the same way that we have APIs to enable the integrations need to know whenever a change has happened in GitHub in order to be able to react to those changes and do their job. We call those webhooks. And webhooks are basically custom messages that we send to specific integrations to tell them that a change has happened within GitHub so that the external applications don't have to constantly poll the environment looking for changes, which is a performance issue. It can chew up bandwidth, all those kinds of things. So what happens instead is that the change happens in GitHub. GitHub notifies that external integration. That integration comes in and does its job. So now, what we've launched, I think the battery's running out in this, is we've now provided webhooks for projects within GitHub. This means that whenever you create a project, update a project, delete a project, right, we trigger an event. Whenever you create a column, update a column, delete a column, move a column, that generates another event. When you create a card, in other words, you're bringing an issue or a note into the columns, basically can move it between columns, update it, convert it from a note to an issue. All of that triggers an event that can go and talk to your external applications, and then they can come in and do something. Imagine the ability for a project manager to be able to drag a card from complete to deploy. That sends an event to your continuous deployment environment. It goes off, does its job. It will then come in and move the card from deploy to deployed. That's the project's webhooks. So that's our developers. Let's now talk about our site administrators, the poor people who've got to keep this thing up and running 24/7. How are we helping them? Does everyone here know what Git LFS is? Some people do, some people don't. All right. So Git LFS is designed to handle the situations where a lot of people are now bringing in binary files, such as images, texture maps, or large data files into GitHub. Git's not designed to work with those files. For example, you can't merge or you can't do diffs and merges on a Photoshop file very easily. Working with large data sets can also cause a problem because it can slow GitHub down as it tries to track the changes. Git LFS allows you to selectively ignore certain files. They're part of your repository, but instead of Git trying to interact with them and slow down, it can just be pushed aside and put out of the way. Game developers find this really handy, for example, because they can keep their texture files in the same directory as all their source code. But they don't want Git to actually try and work with it. So what we've announced is the release of Git LFS 2.0. There we go. All right, so there's a blog entry on it here. And there's a couple of things that we've added to Git LFS 2.0, which is a project that we've released and contribute to, but it is a community project that allows people to have to work with these types of files to get a much better experience within Git and GitHub. So firstly, we now support file locking. So a common workflow, for example, again, for game developers or anyone working with a binary file is because you can't merge those files easily, they can lock the file. Nobody else can check that file out or make changes to that file until I finish with my changes, push it in. Everybody else updates, and then they can work from there. There were some requirements in terms of the Git client in version 2.1 that we had to update to allow for, so that's kind of a bit of a behind-the-scenes support there. And the other thing we've done is we've actually sped up the whole process of moving these files between your developers' laptops and the Git LFS server in itself. Made it faster, made it more stable, made it easier to deal with things like network dropouts and so forth. The other thing we've done, I think this is really important, especially in the government circles, is we've now added the ability to restrict the deletion of repositories. All right, so we can have it so that nobody in the organization, except for the site administrator, can delete a repository. So here I am going into the admin center, and you can see there's an option here called users can delete repositories. I disable that, and at that point in time, only the equivalent of the root user can delete a repository. Especially for organization-owned repositories, you need to keep this stuff. You just want to make sure that people can't delete it accidentally. So here I am, I'm an administrator in this organization, and I still can't delete this particular repository. The last one I want to talk about today is disabling insecure cryptography. So in February, we announced that from February next year, we are going to drop support for TLS version 1.0 and TLS version 1.1 from our product. That's going to happen in February on github.com, and it's going to happen soon after for GitHub Enterprise. However, there are customers who come to us now and they say, I actually want to be able to delete these now. I'm ready to roll. I don't need 1.0 and 1.1, which we all know now is insecure. So now we've provided an option to be able to turn that off now before we completely remove it from the product next year. We do ship it turned on by default for everybody because the last thing we want to do is change the behavior during an update by turning it off automatically. So this is something you opt into. But basically, you can then uncheck TLS 1.0, TLS 1.1 if your environment is ready for it, and you've gotten rid of that insecure cryptography. That is a bad word to say after lunch. Cool. So that's enough of the GitHub stuff. Let's talk about some automation processes. So what I want to do now is I'm going to take you through a scenario where we're going to use GitHub and Jenkins to automatically deploy Lambda functions as we update them as developers. There's some assumptions I've made here. This is actually part of a longer presentation, so I'm going to talk about what I would normally show you, but we've cut for time. Firstly, is I'm going to assume that you know how to use the AWS command line interface. This is a very wordy slide because AWS told me I had to use the proper titles for all the products. So we assume that you know the AWS CLI. We assume that you know how to use the AWS Identity and Access Management console to create an administration user that we're going to use to programmatically update the Lambda function so that we don't have to go in and do it ourselves. Obviously, you know what a Lambda function is. That would be a good assumption to make. And that you know how to use Amazon S3 storage buckets. For this particular environment and for this particular scenario, I'm going to assume that you know what Node is and what Grunt is. So Node's an execution environment, allows you to be able to execute JavaScript and CoffeeScript applications. All I've installed in my development environment, which happened to be that laptop just sitting there above the normal stuff that goes in, is Node.js. I installed a specific version because this is the version that Amazon supports in the AWS Lambda function. So I'm trying to make sure that my environment matches the AWS Lambda environment. I've installed ImageMagick because we're going to just resize an image. And then, obviously, I've installed the AWS command line interface tools. I've also created a user, an administration user, that we're going to use both to test from the command line, as well as used by Jenkins to actually test our deployment processes. And I've also created a role that we're going to assign to the Lambda function that gives it permission to access S3 buckets. Just because you have access to all the AWS stuff doesn't necessarily mean that they automatically talk to each other. It's really important from a security perspective that you make sure that your functions are given the exact permissions they are needed and no more. So let's do this. Let's create the AWS environment. First thing I'm going to do is create our buckets. We're going to create two buckets. The first one's going to be called Afray Lambda Pix, and the second one's going to be called Afray Lambda Pix Resized. And we're going to put an image in one, and our function will eventually resize it and put it in the other. So I'm just creating those now, and I'm spinning through the default permissions mechanisms. So I've created my two S3 buckets, and what I'm going to do now is I'm just going to go in and I'm going to upload the image that we're going to test with. So I click on the Add File button, and I just navigate to, strangely enough, the Octocad image. And now I've uploaded that, and it's sitting in our environment. So now we've created the S3 buckets, and we've put a test image in there to work with. I obviously need to create an AWS Lambda function, otherwise we've got nothing to work with, so let's do that now. So this time now I go to the Lambda console, get started. It's just going to be a blank function. I'm going to skip the triggers for now because we'll get to that. But we're going to call it create thumbnail. And you'll notice too that we're going to run it in Node.js 6.10. Again, consistency of environment is important. I'm not going to add any code to now because obviously we're going to do that programmatically. But we do have here the handler. And what this means where it says index.handler is that AWS Lambda is going to look inside a file that's called index.js for a function called exports.handler. All right, so that's obviously something we need to create. I'm going to add that role, Afray Demo Lambda role, that gives it permission to access the S3 buckets. And then we're going to give it some memory to play with. So I'm going to give it a gig of RAM, because obviously I need it, as much memory as I can get. And I'm going to give it a timeout of 5 minutes because I'm a terrible developer and I'll probably write some bad code at some stage. All right, so now I've created my function. And I'm just going to quickly test to make sure it works. So we're going to do a quick hello world on it. Yep, so everything's executing fine, so we're happy with that for now. Next thing I need to do now is obviously create that trigger so that we know when this is going to execute. All right? We don't want to tell it to execute. We want to tell it that something's happened and it makes the choice. So I go back in and I click on the Triggers tab. And this time around now we're going to add a trigger. And because we're interested in when something happens in an S3 bucket, we're going to pick an S3 trigger. It gets us a bunch of information we have to supply, including the bucket that we're interested in watching, which is Afray Lambda Pix. So there it is here. We're interested in when something creates an object inside the bucket, so we're going to go to the object created. And I'm going to filter it. I'm only interested in JPEG images to resize. So I'm going to say if the file has a suffix of JPG, which is a gross generalization, we're going to assume that that's an image that we want to resize. My code's not going to check to make sure it's an image. That's beyond this. So now we've created our trigger such that whenever a JPEG file is dropped into the Afray Lambda Pix bucket, our Lambda function will go ahead and do its thing. Let's set up our development environment quickly. Going to configure the AWS CLI tools. So what I'm going to use now is that administrator user that we created before so that we can go in and test to make sure that that connection happens. So here I add is my secret access key and my secret ID key of that particular user. I provide the region name I'm working in, which is the Sydney region, AP Southeast 2. And I want all the communication to come back to me in JSON. So I just set that by default. I now test. And the way I test is I basically execute this command here that gives me all the list of Lambda functions I've created in this region. And you can see that we're in the AP Southeast 2 region, and you can see it's the create thumbnail function. So we know we're talking to the right region, and we've got our right function there ready to go. Let's create our project locally that we're going to use to develop that actual Lambda function. So here I create a directory, and I'm going to change into that directory. And because we're executing in Node.js, we need to actually build a Node.js project. So the first thing I'm going to do is create my Node.js package file. I'm going to describe all the packages I need. There are several things I need, like communication with Lambda. I need to create a package that actually does the image resizing, that talks to ImageMagick. What else have we got there? We've got the NPM modules, and that's probably about it for this. So now I've created my package. Obviously, then I now need to actually install. So let's do our install. So now it's grabbing all those packages I need to execute my Lambda function and making them available. Yep, there's a bunch of warnings and things like that. I've been a bit rough about this, but you can see now that I'm ready to go. So let's now build something. First thing I need to do, like I said, the AWS Lambda function is going to look for a function called exports.handler sitting inside an index.js file. So let's create that. I am not going to type all of this. It'll fade out, don't worry. So here we are creating our JavaScript function with all our dependencies, all our variables, and so forth. Instant. So we set up some global variables. We set up some communication with the AWS environment that allows us to do things like download the image and so forth. And then we have our function, our async waterfall function. So in turn, we're going to download the image, then transform it, and then upload it to the other bucket. But at the end, if we have an error at any stage along the way, we're going to be able to report back an error. So that's our Lambda function. Now what we need to do is actually create the files to test. So I'm going to create a file now called a grunt file that's got three commands in it. So here we have the Lambda invoke command. We're going to use that to test. We're going to pretend to be AWS Lambda and actually execute that file. We then have two other, I'm sorry for those of you that I'm in the way, apologies for that. We have a Lambda package and a Lambda deploy. The Lambda package is going to grab everything that we need, compress it up into a zip file, and get it ready for it to be deployed in AWS Lambda. The Lambda deploy function will actually do that deployment. Now, we'll only use that. In fact, I've skipped that for this demo, but you would use that locally on your machine to test the deployment capability. But we're going to use something slightly different with Jenkins later on. So we've created our grunt file. Now what we need to do is, because we are pretending to be Lambda, we also need to pretend to get an event to actually react to. because we're not sitting there waiting for somebody to put a file into the S3 bucket. What we're actually doing is we're going to pretend that that event is happening and then react to that event. So this file here just basically describes an event that would get sent normally to Lambda about the creation of the test file that we created in the S3 bucket. So I'll just create that now. Zoom through again. And the important thing to see is that we've created a file where we talk about the fact that the Octocat AWS Jetpack file, that JPEG file that I uploaded before, has now become available. So this provides the event data that we need to trigger our test with. So we've done that. Let's test it. So here's our S3 bucket. Here is our file. And if I go to the resize bucket just to show that it's still empty, I'm going to flick back now to the terminal and issue the command grunt invoke lambda. Oh, lambda invoke. So it's now running that task based off that event file. It's downloading the image, resized it, and uploaded it, and we get our success message, so everything's okay. So if I go back into the S3 bucket and reload the page, we can see now that we have an image, resized Octocat. I'm going to grab that and download it. And we're going to have a look at that image in the Finder. Here's our original image that's 2560 by 1440, and here's our resized one that's kept within our dimensions of 350 by 350 maximum. So we know that our Lambda function now works. We're happy with that. So how do we then go through that process now of getting into GitHub and automate it so that every time we change that function, it automatically goes across to Lambda? So let's do that. I'm going to get it into GitHub, and I'm running out of time, but that's okay. So here is our environment. I issue the git init command, which we all know as developers. I'm going to add everything. So now I've added everything. I'm going to do our first commit, so that we're actually now starting to track changes to files. And now I'm going to actually upload it to our GitHub repository. So I've added my GitHub repo as the remote. I'm now pushing everything up into GitHub. Away it goes. And we're done. All right. So now next thing I'm going to do is set up our automated build environment. So this is Jenkins. I just used the AWS Linux image, the standard one that's out there. And I've used the yum package manager to just install Jenkins, fired up Jenkins. So that's all I had to do on that front. And then using the Jenkins interface, I installed these three plugins, AWS Lambda, Node.js, and GitHub. So let's now configure Jenkins. Firstly, we'll configure the Node.js plugin. So basically what I have here is I've created the Node.js plugin to also use, strangely enough, as we scroll down. Here is our Node.js installations. I've also created an environment that runs under Node.js 6.10. So our Jenkins environment now matches our development environment, which matches our Lambda environment. So that's our Jenkins setup for Node.js. Now I need to create the Jenkins build project. So let's create a new job here. We're going to call it Create Thumbs Lambda, and it's just going to be a freestyle project. Here I configure it. Firstly, I'm going to tell it that it's a GitHub project. This is purely a cosmetic thing. This allows me from the project job page in Jenkins to be able to link straight through to the repository that we're working with. So we'll drop that information in there to make it easy. We know that our source code is sitting in Git, so I'm going to provide the URL of the repository along with some credentials to make sure that we can get in there legally. And that we're only interested in changes to the master branch. So it's not going to do this for every branch that's in there. We're interested in receiving an event from GitHub whenever the change is made so that we can go in using the API and get our stuff. We're going to execute this in Node, so I'm providing the Node environment to Jenkins to work with. And then we're going to create two build steps. The first one is a script that we're going to run. That's firstly going to just print out some debugging information, so if there's a problem here, we can figure out what versions of software we're using. And then we're going to use that grunt lambda package function that we wrote before in our grunt file. Oh, it does an npm install to update all our packages, and then we run that file. It's checked out the repository, it's going to zip it up and get it ready for deployment. The next thing we're going to do is use the AWS Lambda plugin to do the deployment. So again, I'm using that administrator account, put in the details. 18 seconds, huh? Cool. Here is our region, Southeast 2 in Sydney. Our function name that we're changing, which is create thumbnails. We'll create thumbnail. And we're also going to replicate the information. So first thing I need to do is get an idea of the role. So we're going to use our role ID so that the function still continues to run with the same permissions. So drop that in there. And I'm going to replicate all the information we put in before. How much memory are we going to use, our timeout, and so forth. Here is the name of the package that I know that the package function creates within the environment. Like I said, we're using the index.handler. And then we add our gigabyte of memory and our 300-second or 5-minute timeout. I'm out of time. Can I have a few more seconds? Keep going. Awesome. See, they like me. All right. Now, important thing to point here is I'm just going to update the code. So even though this information is here right now, it's not going to overwrite what's already sitting inside of Lambda. However, you may decide at some stage to actually go ahead and overwrite that information directly from Jenkins, which you can also do. This might be handy if you need to reset it every so often because someone keeps going in and changing it. All right. So now that we've set up our integration to come in and talk to GitHub, do the packaging and send to Lambda, we now also have to need to set GitHub up to actually tell Jenkins to go do its job. So we'll add a webhook there to do that. So I'm now back in my code, and I go to Settings, and I go down to Hooks and Services, and I look for the Jenkins GitHub plugin. I add it, and all I need to do now is provide it the address of my Jenkins server. So I copy and paste, along with one little bit at the end here, and that's the GitHub webhook, all right, because that's the standard address that we send these events to. So I've now created my connection between GitHub and Jenkins. I've added that service. I can go in and test that service, which we'll do now, just to make sure that that communication is taking place. Click on the test service. We go back out, and we can see now we get the little green tick to say that the last delivery was successful, and everything has moved across. So we're good. Let's now kick this off and do something. So I'm going to go back into my source code, and I'm a terrible developer, so I'm modifying the master branch. So I go into my index.js file, and what we're going to do is we're going to change the maximum size to 500. So width and height is now set to 500. I add a commit message because I'm not that bad of a developer, and I commit my changes. If I go now into Jenkins, you can see straight away that we've got a build starting. So the trigger has come across, our build is now running, and by the time I get in there, it's already complete. So if I scroll down, we can see that we've got a success. So as far as Jenkins is concerned, it's worked, but has it really worked? So let's go find out. Let's go and have a look at our buckets. We've got that one resized image in there. And then we have our original images here. I'm going to upload another image into that bucket, and we're going to test to make sure that that trigger works. So I'll just rename this one, call it second. I'm going to upload that into the S3 bucket, our AWS Lambda Pix bucket. Click through the preferences. It's uploaded there. If I now go to our other S3 bucket, our resized Pix bucket, you can see it's not there, but if I refresh it, there we go. So there's our image, and we'll download that and have a look at it. And our first image is 2560, but our new second version is 500. So we know that the change we made within GitHub was automatically propagated by Jenkins to AWS Lambda. So now what? Well, you've got it in GitHub, so you get all this stuff. You get to do things like branching and pull requests and code review and protected branches and everything else that we can give you as a product. Publish this Lambda function as open source. It's going to change the world. You can collaborate with other people, become part of a bigger community, and there's a lot more you can do. There's a whole bunch of release notes, and as Sharon said before, mental blank. Don't worry about writing all this down. You get access to this presentation along with a recording afterwards. And one more thing to be aware of is our government community, government.github.com. We have 32 Australian government organisations already part of this community. We need a lot more, so we really want you to come in. We have state and federal government organisations who are already working together actively. So that's it. Thank you very much.